Welcome to the presentation of JUnitGenie, a framework for path-sensitive unit test generation with large language models. Unit testing is essential for software quality, but writing and maintaining tests is time-consuming and complex. To reduce this burden, researchers have explored automating unit test generation. Traditional approaches are heuristic-based. They rely on predefined rules like semantic reasoning, thus struggle with complex program constraints. Recently, researchers have begun using large language models to generate tests. However, current LLM-based approaches lack symbolic reasoning abilities, making it difficult to handle tests that require precise program behavior. In addition, they are path-insensitive, which hinders reasoning about control flow branches or deeply nested structures. Moreover, many approaches prompt LLMs with limited context, forcing the model to guess missing dependencies. Even when full context is provided, excessive irrelevant context dilutes the model's attention from the focal method. To address these challenges, we present JUnitGenie, a path-sensitive framework that guides LLMs to generate tests with minimal cognitive overhead. JUnitGenie is built on three modules: context knowledge extraction, context knowledge distillation, and test generation with feedback loop. Starting from a Java project, JUnitGenie extracts comprehensive code knowledge. This includes type information, control flow information, and data flow dependencies. All this information is stored in a code knowledge base, which we later use to retrieve relevant context. Second, for each focal method, JUnitGenie explores its control flow graph. Instead of analyzing the entire graph at once, it traverses each path individually. From the code knowledge base, it retrieves only the minimal required context: the focal method invocation strategy, the dependent variables, and the dependent method constraints. Finally, the distilled context is composed into a structured prompt and fed to the LLM. Since the generated text may have compilation or runtime errors, JUnitGenie applies a feedback loop. It captures the error messages, refines the test, and repeats until we get a fully executable test. Now let's look at how to use JUnitGenie in a real-world project. We have published our artifacts on GitHub. Now let's follow the GitHub instructions to run the tool. First, we clone the repository and set up the OpenAI key. Here, we open the configuration file and paste our key inside. Then, we should navigate to the target project and compile it. After this step, we go to the project information extraction directory, and then run the code mining step to analyze the project. Then we return to the root directory and extract code entities and their relationships. Here we can find the extracted code knowledge under the directory code knowledge base, such as the entities and their relations. We also automatically generate a script to load the extracted code information into the Neo4j database. Now, we run this script to load the code knowledge into Neo4j database. Then, start the database. Finally, we can run the path-sensitive generation script by specifying the method fully qualified name, the project directory name, and the package name. We can generate tests for any method in this project. For example, I can change the target from the compile method to another one. All generated tests are automatically stored in the test folder of the target method. For example, here is the test for the first execution pass of the compile method, and here is the test for the first execution pass for the wrap method.